Good morning. Today we are continuing with our Unit 10. We are doing CO64. I can classify a polygon by its sides. So a polygon is a geometric figure made up of 3 or more line segments that intersect only at their end points. So it's those closed figures that we've been working with. A triangle is a polygon with 3 sides. Tri means 3. So the beginning part of our name tells us how many sides there are. A quadrilateral has 4 sides because a quad means 4. So quadrilateral is a polygon with 4 sides. We have different types of quadrilaterals that we know. A trapezoid is a quadrilateral with 1 pair of parallel sides, and then it slants. We worked with the trapezoid earlier, finding the area of a trapezoid. A parallelogram is a quadrilateral with 4 congruent sides. So that quadrilateral would be like that, like a rectangle. A rhombus is a parallelogram. Something like that. They've got parallel sides with 4 congruent sides. A pentagon. Penta means 5, so there's 5 sides. Hexa means 6, so a hexagon has 6 sides. Hepta means 7, so it has 7 sides. Octa means 8, so it has 8 sides. Any guess how many sides a nonagon has?
9.
Nona means 9. Deca.
10.
A decagon has 10. You should know the first 10. In this assignment, we're only going up to 8, but you should really know 10. Nona, 9, deca is 10.
13 is
No. Nona has N-O-N. November is N-O-V. December, no. Months don't follow.
What's 90?
Yeah, because there's like.
Okay, friends, let's stay focused. We know a diagonal is a segment other than a side that connects 2 vertices of a polygon. So that diagonal, it's not just like a diagonal in a circle. The diagonal can be in a polygon. It's connecting on the inside of our shape. So if we have a pentagon, a diagonal is connecting 2 vertices. So diagonals connect those corners. Okay? Let's move it up. And let's see how we're going to work with these. Classifying a quadrilateral. Draw and classify a quadrilateral with opposite sides parallel. One side length is 3 centimeters, the other side is 1 centimeter. So they are parallel. Opposite sides are parallel. What might it look like? Real? Could look like a rectangle. Is it just going to be a rectangle? We could have a parallelogram as long as opposite sides are parallel. So one side length is 1 centimeter, the other is 3. So it's not telling us exactly what it looks like, but it's giving us an idea. So if they're telling you to draw one of your shapes, you really have to think of what it's going to look like. Number 2, classifying polygons. So I was trying to find examples to put on here, and I was having a hard time finding good examples, so I'm going to have to draw them for us. So this is 10.4. So if I draw this shape, draw it a little better. Is that a polygon? What kind of polygon would it be? If it is a polygon, tell me what its name is.
I don't think it's not a polygon.
So Peyton says he doesn't think it's a polygon. Why not?
Because it doesn't have this.
It doesn't have what?
Side.
Well, it's got a side here,
Like,
and it's got a
it's
side
not-
here. But it's got that curve.
Oh, yeah.
And remember, a polygon can't have curves. It has to be connected at endpoints. That's not connected at an endpoint. There's a curve to it. So it is not a polygon. What about this?
Yes.
Is that a polygon? Thumbs up, thumbs down.
John.
What type of polygon is it?
Oh.
So is there endpoints that they're all connecting?
Yeah, but
Yes, so there are endpoints. All the line segments are connected at endpoints, so it is a polygon.
Oh, it is. Okay.
It is a polygon because it is all connected. What type of polygon is this, Tristan?
Pentagon.
A pentagon because it has 1, 2, 3, 4, 5 sides. Because it has 1, 2, 3, 4, 5 sides, it is a pentagon. Pentagons don't always have to look the same. If it has 5 sides, it is a pentagon. So to classify our polygons, you have to count the sides. If it doesn't have a side because it's curved, or it doesn't have a side because it's open, it's not a polygon. Not a polygon, not a polygon. If it is a closed shape with all straight line segments, count the sides to know what type of polygon it is. Make sense? All right, let's look at using a regular polygon. So a regular polygon has all equal sides in length and angles in measure. So would this one right here be a regular polygon?
No.
No, because they're not all the same side lengths. To be a regular polygon, it has to have equal side lengths. You're going to use those diagonals that we talked about to divide the polygons into triangles to find the sum of the measures of their angles. Do we know how many degrees a triangle has? Anthony. 180. That's our magic number for triangles. So we want to divide our polygons into triangles because we know triangles always have 180 degrees. So let's say we want to find the perimeter of a regular pentagon with a side length of 3 feet. It's regular, so they are all the same length. Each side is 3 feet. How can I find the perimeter? How would I find the perimeter of that, Mia? I could add all the sides up. 3 plus 3 plus 3 plus 3 plus 3. What's another way that I could do the exact same answer? Real. Yeah. No, not 3 to the power of 5, because that would be 3 times 3 times 3, and we want to add them. 3 times 5. So we could do 3 plus 3 plus 3 plus 3 plus 3 is the same as saying 3 times 5. We get the same answer. So our perimeter is 15. Now I need to find the sum of the angle measures in the pentagon, but it's not giving me any angle measures. What did I say we need to do? Real? I need to use diagonals, so going from corner to corner to break it into triangles. How many triangles did I break it into? 3. How many degrees is each triangle? So each triangle is 180 degrees. So how many degrees is my whole pentagon?
720. No.
What math are we going to do, Josie? I would add them all up. I could say 180 plus 180 plus 180. What else could I do? Real? Yeah, 180 times 3. And I get 540. Either way, you get the same answer. So there are 540 degrees in a pentagon. In a regular pentagon.
Oh.
It has to be in the regular polygon. You break it into triangles, a regular polygon. So let's say we're going to do, let's do a stop sign. What shape is a stop sign? How many sides does a stop sign have?
8.
So what type of polygon is the stop sign, Will? An octagon. What do I have to do to find how many degrees are in a regular octagon? Break it into triangles.
Yeah.
Oops, that's not a triangle. So I need to go from vertex to vertex. So I have one, can't draw very well with marker, but I have 1, 2, 3, 4, 5, 6 triangles. So what do I do to find how many degrees that is? There are 6 triangles. Josie?
180 times 6.
180 times 6. 1,080 degrees in an octagon. So break it up into all triangles. You can't have any trapezoids in there. They all have to be triangles. Break it into all triangles. Aiden, your eye should be up here. So when we get to this page in our workbook, we should know to break regular polygons up into all triangles. Add those diagonals so all you see in the polygon are triangles. Then count how many triangles there are and multiply them by 180 degrees because each triangle is 180 degrees. Please stop. So we are working on page 133, 134. Do we have any questions on this? When you are done with your page, Khan Academy, I assigned it on Friday. I know I got to it at the end of class time on Friday, but I did assign it. Nobody worked on it over the weekend. Khan Academy is due Thursday. So you do have Khan Academy due Thursday. You were told Friday I was assigning it, so it's your responsibility to remember to get it done. I was a bit surprised that I had given people an extra week to finish up the last Khan Academy, and there's quite a few of us that didn't do it. That's affecting your grade now. Now it's listed as missing in your grade. So make sure you get caught up in Khan Academy. Again, after school accountability is on Monday. So make sure we get that taken care of. For my friends at home, we hope you are well, and we hope to see you soon.